Oh, hello, good morning. Yeah, I wasn't on the stream yesterday. My girlfriend had an appointment, so I had to help out. Yeah, things are relatively good. It's so fucking annoying. Like, my girlfriend was out strolling Oscar, our baby, 5-month-year-old, and she meets a friend who's actually coming home from kindergarten with her son, who's like snot everywhere, right? And then, of course, this friend of my girlfriend, she sticks her fucking head to look at Oscar, and the day after, he's full of snot. Um, and the thing with babies is that they're not able to like get it out, so they sleep really bad. They have trouble eating. Yeah, it's horrible. But on an upbeat note, like it's really nice to get into routines where like things are constantly changing, but you know exactly what to do. You always have 3 steps ahead. It's not like, oh, what's happening now? I'm like, I have no idea what to do. It's like, so last night, for example, by the way, I have to get this out before we can start. So last night, Oscar wakes up at 1, typical in the night. Typically, it's to eat and just go straight back to sleep. But this time, he was wide awake. And I tried to give him food, and it's like, oh, this isn't working. Okay, let's try to pick him up, relax him. Doesn't work. Okay, let's put him in the carry thing, put him to sleep. Doesn't work. And at this point, I've been going on for an hour. But I'm ahead. I have steps ahead. And then I go to my girlfriend and says, sorry, like you have to take him now. I've been spending an hour on this, and I think you just have to start again. So she goes down and tries to give him food again, and now it works, right? That's the thing with babies. You kind of have to, you do this thing for an hour, and then you just have to restart all the time. So like debugging a baby is just insane, because it's not, the initial problem isn't the problem you're actually solving at the end, debugging a baby. Anyways, yeah, I talked to a colleague. It's kind of weird how, like, I'm actually super exhausted, but for some reason, and I noticed this with colleagues as well, who also have kids. Like they're very creative and full of ideas and very productive, even though they're like by default exhausted, which I find really curious. And I feel the same way. So this weekend, for example, I had this big revelation around our architecture and how we deal with side effects. So I thought I would try to explain what this is, like the short version, and then we're going to play around with the Excalidraw project to fix something there. I hope I remember to push. Did I remember to push? Family Scrum, is this? Yeah, this is Firebase. Let's see. Let's do a yarn. Yeah, that's in there. That should be there. These tests should be, yes, great. Okay, so the issue is when you're working with React and they want to run an asynchronous side effect, the only way to, like the way we deal with that today, typically, is using promises. It's very like the mental model for promises is very straightforward. I remember when promises was introduced, like it broke. I remember a presentation by, is his name Dominic or something? And he wasn't able to, like, people didn't get it. I didn't get it. And he had to like adjust because he had been so deep into promises. And it was like a big new thing. But now promises are so like inherent part of like how we write code. So we don't think about it. But those were not easy to understand in the beginning. But anyways, this is like our go-to solution for dealing with asynchronicity. And especially after we got async functions in JavaScript, they become even more popular because like line by line, it's very expressive, but they have problems. They have two huge problems. One being related to running in React, and the other being related to TypeScript. The thing with React is that if you have, I'm calling it feature here, but imagine it's a component, and you have like a use effect hook, and you go and you grab some a sandbox in this case, and you wait for a result of that. If this component unmounts in the meantime, React detects this as a memory leak because you're running something inside the component after it has been unmounted. So that just points to that this is really not the right solution for React. The other thing is that with promises, you have a catch. Like you have then and catch. And in the catch, it's not typed. You can't type the catch. So you can't ensure that you deal with errors. You can't even ensure that, well, I guess that like you can always completely ignore errors. But in this case, you don't know what errors you're getting. So you don't know if you're covering all the errors and so on. So promises aren't really that good. And the way we try to mitigate this in React States is using a concept from Rust, and other languages have similar things, where we basically wrap a promise. It's still just a promise, but we wrap it. So when you do a get sandbox in the feature, and you can return that from a use effect hook, and it actually returns a disposer. It doesn't return a promise, it returns a disposer. And then we have like custom callbacks, like we have a callback for an OK result, and then we have an object which represents, the keys represents the different errors, and it's exhaustive. You have to define what you want to do with every kind of error this result can give. And that certainly helps, but at the same time, it's fundamentally a promise still, meaning that this request response is tied together. And what's funny about this is that one thing that we have solved now inside what we call a feature is that like the UI is event-based. It's like you just send a message into the feature or into the reducer, and then maybe that will result in a new reconciliation, but it's not tied together. It's not like you call a function and then you await that function and then you kind of continue. You can do that, but that's also like an anti-pattern. So it's this decoupling of requesting something, and at some later point in time, you will kind of get what you need, or some new information comes back that will drive the application forward or the UI forward. So that made me think that what if we did the same with the API effects? So instead of you calling get sandbox, it's our oldest. If you can hear that, our oldest is preparing for kindergarten. Oh my god. Anyways, so you're getting a sandbox, but it doesn't return anything. It's just a call, and like the typing is void. And then like the API effect will actually go and grab a sandbox, but instead of returning like a promise, it will emit events. So it will emit, in this case, a sandbox OK event or a sandbox error event. Now, the interesting thing is that this feature actually subscribes to the API effect itself. And the way it subscribes to it is that it basically funnels any event coming from the API effect into the reducer. So it's just like, it's a one-liner, API effect events, send into reducer. And what's interesting about that is that these event-driven architectures are unwieldy. Like, if you just have an event hub spitting out events in all directions, and you have to manually subscribe and dispose of it, it's impossible to deal with all these events. But since we have these explicit states, they kind of act as a, what should I call it? Yeah, I don't know the term, but the point is that this feature is in a specific state now. It is in loading sandbox state. And in this specific state, it's waiting for these specific events. So this is how it's completely decoupled, but still it's tied together. So it's not like this sandbox OK event suddenly changes the state of the application. That wouldn't work, right? So if we did this concept around a plain reducer, like a traditional reducer, where the event or the action goes in and just changes the state, and then everything reconciles, that would be a problem, because then it will be the API effect that drives the application forward. But that's not the case here anymore. It's a reducer. It doesn't matter if it's a UI event or an environment effect event. It's the reducer that decides, okay, I'm in this state now. These are the events I care about, and they are allowed to drive the application forward in this specific state. Yes, and then what was this about? Yeah, so what's interesting about this is that we kind of get some superpowers. First of all, when we get the sandbox, we can actually get a synchronous result back. With promises, it's always async. But here we can do what's the right thing. Like we can do a synchronous event based on the request, or we can do an async event, or we can do both. Like first we send a synchronous event, for example, related to a sandbox being cached. But then as we send that back, we do some more work inside the effect. We go and grab the latest sandbox, we update it, and then we send another event about, okay, we updated the sandbox now. And again, these explicit states decides what's going to happen. So in this case, we're loading a sandbox and we're getting a sandbox back. And then when we are loaded, we still allow updates to the sandbox. Yeah. And as I was exploring this, I constantly found benefits of doing this. One thing being able to just look like you add a type. Like in this case, you would add API event as a type of event in your reducer. And suddenly you just get an API inside your reducer. And you can just choose within each state, which part of this do I want to do now? Now, the interesting thing is that when you do have this subscription, like any event from the API will actually reach the reducer, which means that this reducer might get a lot of unrelated events, like you never add them to any of the states. But that doesn't matter, because even though it's not being handled, the reducer will return its existing context in this case, and React doesn't do anything. It's just a simple check, like, is the new context the same as the old one? Okay, drop it. Then it just stops running. So it's extremely cheap to do that, even though it seems inefficient, but reconciliation in React is also inefficient, right? It does a lot of checks it doesn't have to do, but it's just predictability of the thing. But yeah, so there's tons of these tiny little things. So for example, in testing, we don't have to use async anymore, because as I said, when we deal with these side effects, we can run them synchronously. So we don't need async tests, which simplifies a lot. We can also do some really complex things. Let's see here. Yeah, so we're working on some new stuff. And the thing is, what if you have a feature that doesn't only have like a top level state, but in this case it represents a file system, or like a file tree, and you want to individually for each folder you want to have a state, like, is it loading now, is it loaded, maybe it has some errors or whatever. The point is that in this case we can do the same thing. So for example, this Explorer feature will start in a loaded state. And what it does is that it looks at in this case the FS effect. It looks at the FS effect. Do I have any file tree here from before, which is a synchronous request, request response, call return. Like every single FS, every single environment effect doesn't have to be this event-based thing. You can still have normal methods. You can use promises if that makes sense for that scenario. But yeah, in this case, it basically just reads the cache. Do we have a file tree? And in this case, it doesn't have that. So what it does is that it starts in a loaded state. So the file explorer itself is loaded, but then it inserts, like at the root, we have an entry that is loading. We're just saying this is the thing we have in our tree now, but it's like loading. So when this feature updates, there's a use effect, like a React states use effect, that looks at all these folders and tries to find a folder that has a loading state. And if it has a loading state, it picks it up, it runs read directory from the FS effect, and then at some point you will get like in this case directory OK or directory error. And since the Explorer feature is in a loaded state, it will deal with those events and it will update. In this case, let's imagine it gets a directory OK. It will give this a loaded state. And what this means is that if we were to use promises here, we would have a really hard time mapping these requests being cancelable, with having multiple requests going at the same time. So you would kind of open two folders very quickly, and then you suddenly have two different results that needs to resolve, and both of them should be cancelable, which is super, super tricky. So the way it does handles unmounting in this case is that it just unsubscribes. That's the whole point. It's like you start a feature, it subscribes to file system effect in this case, and whenever it unmounts, it just stops listening to these events. And so you can imagine like going to a folder or directory in the UI, and you send in, like you click it and you send that event into the Explorer feature. That Explorer feature will try to we'll put that folder selected into its state as a loading indication. Again, the effect inside the Explorer feature will see that, oh, we have a new folder with a loading indication. It reads the directory. It might actually get a synchronous response this time, which immediately updates the this one to loaded. Or it might be asynchronous. We don't really care about that. It's just as efficient as possible. Yeah, so that's like how it runs. And then what's also really cool about this concept is that since like promises are local, which means that if we were to use promises here, it wouldn't be like, it would be this specific feature trying to get a folder from this effect. But when we have this event-based approach, this read dir here, it doesn't matter who does it, or everyone who cares about file system events will actually get them, no matter who requests the data. So that means that if someone already had like or some other component or other feature was looking at the file system, it would also get an event about the source folder now being loaded, which is really, really cool. Yes, I think that's what I wanted to talk about. So let's see it in let's see this in code. Let's look at Yeah, let's look at the effect. Yeah, and of course I got a cold as well. Like I'm not feeling good at all. So that sucks. Let's see. So the way we do this. So previously our storage was just a bunch of results. And well, maybe we should look at a simpler example, just so you don't have to look at all that code. So previously this sign-in had a result, and then it had a custom subscription thing related to the authentication changing. But now what we rather do is that we define a set of events for this environment effect called authentication. And what's really good about this is that you create specific events for what's happening, but also errors. So you don't have this artificial generic error thing that we had with result. Like we were kind of excusing results with having explicit errors, that exhaustive errors that you had to deal with. But typically it would end up with just a generic error, right? You would have the same problem as try catch. You kind of just catch everything. But here with these events, you are encouraged like beforehand to think about where things can go wrong. So in this case, a sign-in might error. And what we do is that from React states now, I'm going to replace result with events. So all you do is that you add some events to this environment effect, and you give it the events it can have. And in this case, this is interesting, like you don't see anything related to checking the current authentication state, right? It's just sign in, which is also really interesting. So in our test now, which is also super interesting, is that we can just add events here, and then we can just make every single method, we can just make it a mocked jest function. And what's really, really cool about that, if we look at the test first, is that should go to previous loaded when mounting and successfully downloading previews. So in this case, I'm just setting up the test. So we're starting in an authenticated state, and we're testing the dashboard here, that we're actually downloading the previews, and we're mocking that data. Now, previously I had to use like async stuff here because the result is a promise, and we would have to like artificially wait for that promise to result. Well, we don't have to do that anymore, because now we can just check. Okay, so we fired up in an authenticated state. What happens in the dashboard? Well, I expect the dashboard to call the fetch previews on the storage. That's one check. And then using a plain act, because this is synchronous, I will just trigger that the storage actually had a successful fetch of the previews. And these are the mocked previews. And then I'll check, am I now in the right state? This is really, really interesting that we're able to do this now. And then for the actual browser implementation, I have some logic up here related to updating the user data. Like every time you log in, I just update the avatar. That's basically it. So this is the implementation. Again, I'm just creating this simple interface here with events and sign-in, where we create our events. And then I immediately start listening to on-auth state changed on Firebase when this effect actually runs. And whenever we get a user, we emit an authenticated event. And whenever we don't have a user, we emit an unauthenticated event. And this just immediately starts running, right? You don't have to subscribe to this or anything. You're subscribing to the whole authentication effect. And then we add the auth events there. And when we do a sign-in, we just do a plain sign-in. And if that errors, we actually we emit the sign-in error event. And the reason we don't have to do the authenticated here is because when you do sign in, this one will trigger again. That's how Firebase works. and it will trigger these events. So the way this is actually implemented in auth is that we have our auth context. These are the states the auth can be in. And then we have, I realized that these symbols that we use, we don't have to use them at all. We can actually separate the events we type in the reducer itself and the events we use on the context. Let's see, I really want these to be there. So the context only has public auth event. So the context is what's being consumed by the UI, right? So we just give specific events to be used in the UI. And the only thing the UI can do is to sign in. The UI shouldn't be able to do trigger any other types of events. But our reducer can actually consume a public auth event or an authentication event, which is coming from this environment effect. And as you can see here, I'm actually consuming these events from the environment effect. So as I said, when I go here, and since I've added the authentication event, I suddenly get like an API for this inside my reducer. Like these are the events I want to handle in these specific states. So when we are checking authentication, that's when it signs in initially or checks authentication. Then I want to deal with these two events. When I'm signing in, that means I moved to unauthenticated. I've clicked sign in, it moves to signing in, and again I listen to the same events. Yes. So that's really interesting. So what would happen here is that I could do like storage event like this, and now suddenly I have a bunch of storage events that I can react to if I need to do so. But it's all tied to a specific state. That's the thing. That's what's enabling this. As I said, like event-based architectures are unwieldy. Like you're not able to control the events, but with these explicit states, you are actually able to control them. And then the only thing I need to do is that I'm saying use events from authentication and send it into the auth states, into the reducer. That's all that's needed to wire this thing up. Yes, that was a long run through, but that's it. And I've been refactoring this Excalidraw thing, and I'm not completely done. So I thought maybe, let's see, hopefully Oscar will stay asleep, and we are going to try to finish this. So let's see, yarn test watch. Well, let's just run the test first, because I think most of them are running green. Oh, are all of them running green? That can't be right. Let's see, because I haven't fixed the auth feature. Why is it saying that's running? That's kind of weird. Oh, skipped. Here we go. I have the only here. Okay, so let's watch, and this is Excalidraw index test DSX. Yeah, so I just started refactoring this one, and as you can see, should go to unfocused when and this actually leads to a refactor of the whole project. I'm going to change how we do things. So we're first going to make these tests run and see if we can get the application running, and then we'll refactor the application. I want to move away from, like, I want to explore like using, well, I guess I don't need to use a cache because the Firebase client itself has a cache, I believe. But we're going to make it more event-based. So whenever you open an Excalidraw, we just set up a snapshot listener, and that's what's driving it forward. We don't need to, like, okay, now you're focused, unfocused, blah blah blah, go and update and grab the data and stuff like that. It's just a subscription running. Okay, so the first thing I did here, should go to unfocus when moving away from tab in edit state. So I changed our visibility, like it was called on visibility. So that's also interesting. This is related to the browser visibility change event. So I just created an environment effect which just has events, and it just spits out visible and hidden whenever the browser tab changes. Yes. And the cool thing is that any feature can just subscribe to this visibility environment effect. And this is also a hidden benefit of this, is that previously let's use this as an example. Previously, I had to have like an event here as well, like type auth success. I had to like double down on it, because I had a promise that resolves, and then I had to implement the event here, because the promise needs to trigger an event into the dispatcher, into the reducer. But now I don't have to have these events anymore. The events are in the environment effect, meaning that the features themselves becomes cleaner. You don't need this translation between a promise and an event. Where were we? Anyways, yeah, so we have visibility, and as you can see, all I'm doing is I'm firing up in an initial edit state, and then I just trigger, okay, hidden, you should move to unfocused. That's all. So let's tackle the next one. Visibility, create visibility. And here we are, visibility false. Isn't this the same? Oh, it's a different state, syncing. Yeah, let's just copy this one. So we want to trigger, and we don't need to wait for anything. Now it's synchronous, so we can just immediately check it. That one's good. So it's so interesting. Like I have this, like going through all of this, I have this feeling that we're just like event-based architectures, like they rule. Like you have the actor model, for example, which is also a really powerful like pattern, or whatever you want to call it. But again, it has the same problem. It's like, how do you deal with these events? How do you control them? And it's funny to see that it's not about like looking at the events themselves and try to deal with them. It's having these states. That's actually how you deal with them, which I find fascinating. And yeah, I have a feeling that like front end, like at least at a certain level of complexity in applications, we're going to have this huge shift. We're going to stop writing our state as we do now, where we just have we represent a single state object which has all the state. It's just a bunch of values, to actually have multiple objects representing the state, where we label it with some explicit name. And we start doing things more event-driven, because that allows us to do things more event-driven. Because it encourages decoupling without losing control. And with that decoupling, everything just becomes easier. It's easier to consume common APIs. It's easier to control. For example, in the example of reading the directory, like what if you want to make sure that you only read, when you read the directory from the server, you want to ensure that you only read one at a time. So like if you get two requests for reading the same directory, you only want one of them to actually read from the server. That's super easy to do. You just keep like you have a map of the state of reading a directory, where you have like the path as the key, And then you can just have a flag like I'm reading, not reading kind of thing. And you don't have to now mess around with promises. So you have like two different promises resolving, and you have to make the resolvement of one promise to resolve the other promise. You just drop it like at the beginning of the. So in the environment effect, you have like read there, and you have a path. So you would just say if, let's say you have reader paths. So let's say this map is like indicates if you're already reading, you just return. That's all you need to do. Because when the first call to this goes to the server, when this resolves, it will emit events on this, right? And these events will go to anyone who subscribes to this environment effect. So it's just incredibly efficient. And you can decide how deep you want to go with this. You can drop this. Maybe it's not necessary. And then you can do this to optimize. And then you can introduce a cache. So that if cache path, you would just say this events emit type dir okay path children will be like cache path, for example. So you just go through and then you kind of build up the complexity you need from this. But yeah, and this is something that's like something we don't really do in applications because it's very complex to deal with caching and optimistic updates and stuff like that. You kind of rely on a library to do that. But in this way of how do you handle the case where data are already loaded? So that's because in the loaded event, well, it depends on how you do it. So do you want to have let's see, let's talk about that. So let's imagine you have like a reducer here. You can say when this is loading, I want to grab storage. Let's just call it data. Loaded, for example. Let's drop the error. It's just data loaded. And then when you're loaded, data loaded, you also want to deal with this. So this one would be, so let's imagine you're in this situation where you don't have a cache. It will trigger this asynchronously because it needs to go to the server first, and you're not doing anything. You're always going to, let's call this load data. You're always going to the server, and when it's done, it emits. I think Oscar is waking up. Let's see. What was it? Storage, data loaded. So we always emit that. So when you're loading, at some point, this hits, and you move to loaded. Yes. And then when you're loaded, for some reason this is being called again, which means that this loaded, it will still be in a loaded state, but you just update the data. Let's see. Sorry, I'm just setting up this a little bit so we can talk through it, like the steps. Yes, so you stay in the loaded state, but you just update the data. And then you can say, okay, on load data, we're going to have a cache for this. There will be like an ID here, of course. And then you would just immediately trigger this. And that means that, and then it will go to the server and update it. What would happen here is that you call load data, it will synchronously fire off a storage data loaded. So it immediately moves from loading to a loaded state. And then it goes to the server and updates the data. It triggers the same data loaded, and it updates the loaded data. And then you can say, oh, isn't that inefficient? And yeah, maybe it is. maybe the data rarely changes. But this is the thing, like having a single caching solution is really difficult to generically handle caching on all applications. But here you can actually choose. So what you could do here, one approach would be like you're listening to, let's see. So for example, here you don't care about further updates, for example. That could be one way to deal with it. Or you could do, you could actually check. So when you receive the data that comes from the server, you would have actually check if the thing, if cache ID is not like data, like this is pseudocode, then you would actually emit the event. So you can optimize like that. Or you could do, I guess you could also have like explicit like cache loaded, for example. Or you could have, I'm waiting for either of these. I'm waiting for data loaded or cache loaded, for example. And then you could do, when loaded, you could say cache update. Like this is just random shit I'm putting in here just to show the flexibility of how you can deal with it. Yes, but you decide. Like if you imagine the way I talked about it, I made a video for my colleagues. So the way I think about this is like, so imagine you have this API effect at the top, and it just sends a bunch of events. Like it doesn't really do that in practice. Like there's not that much going on in an API effect, but it just pushes events down into the application, and it will hit like a ton of reducers. And most of these events aren't actually being handled, because in a loaded state, for example, maybe you don't have anything there. So like it hits the reducer, but what you do here is that it doesn't find, like you're not actually dealing with the event. So the reducer will return its existing context or state, and nothing happens. There's no guarantee that you will pass by the loading state before. Well, yeah, you have the guarantee because you start the reducer in the loading state. Maybe this example doesn't show the flow that nice. It's like, so you have use reducer, data reducer, and state would be loading. So you start here, and then in the use effect, you will do like storage, get data. So that ensures that like this call guarantees that you will get data loaded event. And then you can do like storage cache ID. Okay, let's start in the loaded state then, for example. So you can start in the loaded state with cache data if you want to do that. Like it depends on how you want to deal with the caching. Does that make sense? Or so I guess what I want to point out here is that the decoupling requires you to, so what could happen, for example, is that you go in here and you use this effect, like you go grab the data, but you forget to subscribe, for example. Yeah, exactly. The event can be synchronous. Which is really interesting. Like this is that's really interesting to me. Like promises doesn't allow synchronous behavior, and I had several situations where I do want it to be synchronous. So yeah, that's the power of events. They can be synchronous and asynchronous. And what's also really cool is like if you have, so for example in the storage we have something called fetch image source. And this is being called like on the dashboard, where you might have like 100 images. I'm not sure if this is the right place to do it, but it's just an example of what you can do. So in this application, fetch image source is something we know is being called like a lot of times. And when it's being called and the event is emitted, it causes a reconciliation in React, loading up images. So what's interesting about this is that you could do something like this event batch emit type image source, whatever, and then you would do like 100. And what would happen here is that since we know in this application that this specific method is being hit very fast, we can batch up events. So they actually synchronously go out to all the components within like after 100 milliseconds, for example. I'm not sure if that would actually improve the experience, but it's just an example. You could also do things like idle emit, for example. So if you know that this event actually causes some heavy reconciliation in React, you could emit it when using request idle callback. Oh yeah, you would call it. Yeah, because that's, yeah, and this is really interesting. Like what you would call this. Yeah, and it's like a mind. It's conceptually how you think about it. The way I think about it is the reducer, the state decides what it's doing now, and then it's up to these effects. Sorry. So here it is like, okay, I am loading now. So when you consume this reducer from the UI, you show a spinner, for example. It is loading now. And then it's up to some effect to, if context state equals loading, let me go and do this thing. So it's flipped around. Like typically we think about it as, okay, first go and grab the data, like put it in loading here, go grab the data, and then put it out of loading after that. While here you're actually like the reducer is the truth. That's the thing that drives it forward, and then it's the effects are reactive to that, and that's a different way of thinking about it. So, but I don't disagree with you. Like it's just how you think about it. So, for example, here you would have like like idle or something, and then you would have idle, and then it goes to grab the data. But in the UI, it looks at it as idle. It doesn't look at it as loading. So the mind shift here is basically flip it around. Think about, typically we think about the reducer as not like the source of truth. We think about it as, well, that's the wrong term. We think about it as being at the mercy of these side effects. It's kind of, it's like these functions we call. So sorry, I'm rambling. So we would have like load data here. So typically this is what you would call like load data, and then that is kind of what drives the application forward. It's this function that drives the application forward. But we're flipping it around. Now instead of calling load data, we're putting it in a loading state and making it reactive. So the reducer will always like say what's the truth now, what is the state of the application, and then it's up to these side effects to react to that to help move the application forward. And that's a decoupling that can that you can argue like can cause well, not bugs, but like things can stop, right? So if you set it into loading state and you have no side effect that actually looks at that state and does something to drive things forward, then nothing would happen. So it's not really a bug in that sense, but it's you haven't covered that state. That's what I mean. So that is certainly, I guess you can call that a drawback. Yes, but all the benefits, like it's all like the benefits are overwhelming to that decoupling. In the case of events, they are the source of truth. Yeah, like source of truth. I guess it's a little bit, if I understand you correctly. What I mean is like the reducer represents the truth of your application. The events is the environment. So it's like, oh, let me bring up the thing. Where are you? There we are. So this is the thing. So if you think about the app here being the reducer, I'm thinking the app here, this is like you have to give a predictable experience, something has to decide what do we present to the user now. And the thing is, what we typically do is that we allow these events that happens in the environment, it being a user click or a URL change or visibility change or whatever, any event happening, that event decides what are we now going to display to the user. Yeah, oh, I'll get back to that, sorry. Yeah, so the events are actually driving the reducer forward. Like they decide, they just dispatch and tell the reducer, I trigger now, do what I tell you to do. But we're flipping it around. We're saying that the reducer first sets, this is the experience now, this is what I want for the user now. And then any event can trigger, like it can be completely unpredictable. But at some point you will actually get the event that you decided is the thing that's going to now move the experience of the user one step further. So you could have 20 events completely randomly triggering in the environment, but it will only pick up that single event that moves, that predictably. Yes. So that's why I wouldn't say like the events are the source of truth. They are the source of what's happening in the source of truth of what's happening in the environment. That's for sure. But that's the problem because what's happening in the environment is so unpredictable. So the reducer becomes like a filter between like the predictable user experience you want, and by just dealing with all these random events hitting the reducer. Yes, that's mentally how I like conceptually think about it. Initial say, guess user event could call send with the latest event. Yeah, I couldn't do it. Like if you run send when in like the body of a component, you will get an error from React. But it could do it like it could do it like with a timeout. But yeah, I'm not sure if it's necessary to do that. Yeah, it's interesting. Yeah, but these are really great questions, because I just gone through this, and what we're doing now, refactoring this, is basically like testing it. So it's a lot of like theoretical benefits where I'm starting to see like getting a validation that this is working. But yeah, we need to refactor the whole thing to kind of prove that it's actually working. And what are like the repercussions around, for example, one thing I noticed is I forgot to do this. So I set up the typing and I deal with the events inside the reducer, but then I forget to set up the subscription. And the good thing is, well, arguably, the good thing is that nothing happens because it just doesn't receive the event. And I can also see that in the dev tool that hey, why isn't this state moving forward? And then I see that there aren't any events there. But yeah, I guess kind of to round up the talk around like the order of the events is like, first you set your reducer in a state, and then the decoupling is that you have to introduce a side effect inside the component which looks at that state, which is tied to that state, to trigger something in the environment that will eventually, immediately or eventually, send an event that this current state deals with to move the application forward. Oh, yeah, because that's okay. I think I know what you mean. Yeah, I thought about this a little bit, because what is the cache? Is the cache, so yeah, let's talk about this. Okay, so you have a storage and it has a cache, and then you have this feature that uses the cache, and this cache is like a bunch of, okay, let's just do sandboxes. Sandbox DTO ID. I'm not sure what language this is. I think it's, yeah, maybe it's TypeScript, almost TypeScript. And then you have this feature that that uses these sandboxes. But the thing is that this is a data cache. This is not like UI, right? It doesn't have any notion of like how should I say it? Like, it doesn't have, if it's not there, is it loading? Has it started loading? What about other related state to this sandbox? That's not about the data of the sandbox, like the entity sandbox. It can be other kinds of metadata related to the sandbox, being completely UI based state, or maybe some other entity tied into that. Like, this is like a pure data cache. So the way I think about it is, in this feature you would have like a context where state would be like, for example, loaded, and then you would have a sandbox. Well, I guess this case isn't, this example isn't the best. But in this case, we are not, okay, so we're not saying sandbox here, because that doesn't really, like, this is how you would do like with, what's it called? Like query fetch, or whatever it's called. Some sandbox one, and then you would kind of get the sandbox back. You would only get the data, but we're not only interested in the data, we're interested in this state, because this is what the UI uses to consume it. So in query fetch you have like sandbox is loading error. I guess this is how it looks. While here we have like loaded, and then we show the sandbox. But what I meant to say is that in the example of the directories, for example, you would have like directories, and you would have like the root, and this would have a state in its own, where you have like the data of the directory, like dir, something like this. So the source of truth for the data would be like the cache, but the source of truth of what to display to the user, that's more than the data. It's like, it's all these states and other related, like maybe you have like a search query, whatever, like it's more than that. So I would call this like data source of truth and UI state source of truth, and it just exposes the data through the reducer. If that makes sense. Maybe I misunderstood your because I wouldn't. Yeah. So maybe a different way to think about this is, what if I were, let's move back to the sandbox. I would have a sandbox here, and then I would have some kind of, sorry for writing really weird pseudocode, but maybe I would call like storage update title, for example. So I wouldn't update that in my reducer. I would do that in the storage, for example. And then I would update the cache in the storage, and I would emit an event that I updated the title. And then anyone who uses that same sandbox would also update itself. If I don't have this cache, I can simplify it. Like maybe there's no, like for example on Code Sandbox, there's no other things that can use the sandbox. Like there's a single sandbox, so you wouldn't have that cache. And then you would just load the sandbox, you would put it into the reducer, and then you would manipulate it inside the reducer. So adding that cache is complexity for sure. Yeah. Yup. And I guess it's the same with the use query thing. Like if you have this, oh, here it is. If you do this and you put this sandbox, like how do you update this sandbox with this? I don't remember what's it called, this query that has become so popular. Again, here it's like, how do you update this? You don't like here you kind of use the data directly in your UI components, but then you have to do all these checks. Like, is it loading? Do you have an error? Do you have a sandbox? What if you have more data there? Like, you don't have any abstraction between the data and the UI, which probably works for some applications, but like the level of complexity we deal with at Code Sandbox, we have to have something between the data and the UI that so that the UI components doesn't have this. Yeah, React query. Yeah. Yeah, something that makes the UI components just trust this. It just uses a feature. It has some state or a context, and that's what it consumes. It doesn't have like a bunch of data fetching logic that can be in different states, and that's where things starts to break down. But yeah, I haven't tried implementing a cache. We are going to do that related to something we are building now. And just caching in itself is really, really hard to do. You kind of like naively, one would think about caching as, okay, I grab some data, I store it in a map, and then whenever I move back to that data, I'll just use the cache. But then the question is, what if that cache is old? How do you go and grab a new one? Because you just returned the cache using a promise, for example. How do you then get the latest version? What triggers that? Was it that you grab it from the cache? Should that trigger that it should go and check with the server if it's updated? But now you've returned the promise. So how do you notify the component that, oh, by the way, there is an actual update there? Which means that the component needs a subscription on that cache as well. So this is what React Query does for you, I believe. It handles this complexity of, okay, you have this suspense thing, which is also promise-based. And it just handles this under the hood. When should it update the cache? And so it's combined cache result and a subscription to the data whenever it updates. So that's basically what we did in our more custom implementation. But the point is, like, when does it actually update? So you might have a piece of data you always want to update, so you don't have a cache at all. Maybe you want a cache, but every time you reach for the cache, you go and check if it's been updated. And maybe you just trigger an update every single time. Or maybe you check the data that comes from the server. Has it actually changed? And only then you actually emit an event that you have an updated cache. Or maybe you have a timer on it. So whenever you reach for the cache, if it is a certain amount of time has passed, you certain amount of time has passed, then you actually go and fetch it to update the cache. Or maybe you just subscribe to changes on the server and you just continuously update the cache. So whenever it's hit, it's actually always updated. But then when you do trigger like an update later, it will also, so you will always have the latest cache because it's constantly being updated from the server, even though no components is using it. But when it's using it, it's always the latest cache. And you still get events when that cache updates, which is also what you want. So that's actually what we're going to do here in Excalidraw. We are going to have, when you reach for an Excalidraw, it's going to set up a subscription, like a snapshot subscription on that Excalidraw. And this will just continue running, even though you move back to the dashboard and you open a different Excalidraw. It will just keep that subscription open and update that Excalidraw. Maybe some other user is updating it. So when you move back to that Excalidraw, it's always up to date. But yeah, this is really, really interesting and very, very difficult stuff to do. What I do like though is that what we've been able to do now is actually talk about this complexity. And we have the possibility to tune it the way we want based on the application. But yeah, it's interesting for sure. It's interesting for sure. And and thanks for like critical feedback as well. I have a tendency to love my own ideas. Like you know when you get these moments of you kind of get into that mode, and that doesn't necessarily mean that, like, maybe I've seen too many movies, like you know those montage scenes in movies where they kind of figure out a problem and all the dots connect. I feel that sometimes, and it doesn't necessarily bring truth to it. In this case though, like the fundamental thing we've done here, making it event driven, has given so many benefits that I'm very confident that it's better than doing promises. But it's going to be really interesting to explore the cache, like how to deal with that. And it's interesting at Code Sandbox as well, because we do have different kinds of sources of data. It's not like some of it is a GraphQL, which has subscriptions. Some of it is a REST thing. What we're building now is based on a service running, based on a different kind of service, which has its own like WebSocket protocol. So yeah, it's different data sources. And it's just nice to have that flexibility of how do you even want the cache? And if you want that cache, how do you want that cache to update? How do you want to notify any subscribers about updates to that cache? Yes. But I guess I should really, we didn't get to do much coding here. But I'm going to continue on this because this is going to be like a reference for what we're doing at Code Sandbox now. So I'm going to fix this, and then maybe we can continue on the app tomorrow. That would be fun. Yeah, or maybe we'll need to talk more about this. But anyways, thanks Etienne for all the questions. And yeah, I hope it makes sense, and at least is a source of bringing up some thoughts and reflections around these kinds of things. Have a good day, and we'll talk tomorrow, I hope. Bye bye.